doing substitution, okay? So we have been working on systems of equations by graphing. So we're still going to have two equations. We're still going to see where they cross. But instead of drawing a picture of it today, I'm going to show you a mathematical way to get it. And it'll give you the exact answer every time, okay? Because we know that when we get on those decimals, or trying to cross at a decimal, we don't know exactly where that decimal's at. We just know about where it's at, okay? All right, so substitution sounds exactly as it sounds. You are going to replace, just like on the basketball court or on the football field, when we substitute somebody, somebody comes in your position and replaces you. It's going to be the same thing here today. We are going to replace a letter. Okay? We're going to take it out of the game and we're going to put something else in its place. Okay? All right, so substitution. A method to find the exact solution. So we're no longer looking at a graph and getting an approximate solution. Or about what our answer should be. Okay? So we are going to get an exact solution for the systems of equations that we're looking at. Now on number one there, you have a grid on number one, and that is so that we're going to go ahead and graph it. Oh, 6-2. Okay, so we're going to do this, but on number one here, I've got a grid. We're going to graph it just to kind of look at it, just to take a look at what we know, and then I'm going to show you the new method, substitution, and how it all fits together. Okay? Yeah, you're going to do what we do, but we're not going to graph after number one. After number one, we're just going to do it mathematically and with algebra. Okay? All right, so now on number one, what are we going to do first here when we're solving for y on that first equation? Emma, start us off.
Divide by 2.
Good, we're going to divide everything by 2, right? Okay, so y equals what?
1/2 x.
Nice job, 1/2 x. Okay, keep in mind there's a 1 in front there. Now, where's my starting position going to be on this guy?
0.
Good, okay, there's nothing out back there, so I'm going to start at 0. And 1/2 of 1 over 2. So go ahead and graph that for me. We're going to do the second equation here. Caitlin, what are we going to do on that second equation to start solving for it?
Subtract 4x.
Good. So we have 2y equals negative 4x plus 15. Okay. Next step, Peyton, will be to do what to get that y by itself?
Divide by 2.
Good. So divide everything by 2. Okay. So y equals negative 2x. All right, what's 15 divided by 2? It's half of 15. 7.5. Very good. So I'm going to start at 7.5. Okay, so when I come over here to my grid and I start 7.5, it's going to be right on top of that arrow. And then negative 2 over 1, I'm going to go down 2 over 1. So I'm still going to be at the halfway point on all these. Down 2 over 1. Alright, so we've got a spot where it crosses. Anybody want to kind of take a stab there? What would that coordinate point be? Well, so just do the best you can. What do you think it'll be?
3, 1.5.
3, I would say 3, and someone said 2, okay, which on your paper it might kind of look like a 2. Up here it's kind of looking close to 1.5, but do we know for sure it's crossing exactly 1.5? You all should be saying no right now. We don't know for sure, okay, because we just hand sketched and we've got an idea. Now we also heard 3, 2 because their line's a little higher, okay? So that's the problem with graphing though, is we can't always tell exactly where it's at, can we? Unless it's a nice pretty whole number a lot of times, we don't know exactly for sure, okay? So what I'm going to do now is I'm going to draw a little wall here. I'm going to rewrite my two equations. So x equals 2y and 4x plus 2y equals 15. And what I'm going to do now is we're going to practice substitution. So this is just a second way of solving this set of equations, but we're not going to look at the picture this time. Okay? Now, substitution. You want an x or y equals. Okay? That's a necessity. We have to have that. Okay? So we have an x equals right on the top one here, don't we? X equals 2y. Okay? So now, before you all start yelling at me on the first problem, give me 2 or 3 examples to get you through it. And then let's start asking some questions, okay? But give me a couple of times, so let me show it to you a few times first, and then let's see what questions you got, okay? So, when you're looking at this, x equals 2y, you're going to replace, okay? So x equals, where am I plugging it in at? So this tells me I'm going to plug in for the x. What am I going to put in there? I'm putting in the 2y, okay? So I'm going to take this guy, and I'm going to plug it into the other equation. All right, I have x equals, so I'm going to take the x out and put in 2y in its position. Okay, so when I do that, it's going to look like 4 and 7x. 2y plus 2y equals 15. So all I've done is rewrote this equation. I just replaced the x with the 2y. Substitution. I replace.
Is it always, are we always gonna replace it with the x?
No, we're gonna get there. But no, if it's y equals, then you would plug it in for the y.
Oh,
Okay.
oh.
Make sense? All right. Okay, so far a question on there? We're good? Okay, now just solve the equation, guys. It's just a lot of equation solving at this point. All right, so what are some things that we need to do here to get this cleaned up?
Add the y.
Okay, well, we can't add the y until we do what?
Distribute.
Well, it's not distribute, really. I mean, isn't it really just multiplication?
Yeah.
Because we're not actually pushing the 4 through to a bunch of parts. It's only one thing there. All right, so we've got 8y plus 2y equals 15. So now Caitlin said add the y's, and she's right. So 8y plus 2y is 10y equals 15. So now I divide. Anybody know what 15 divided by 10 is? Okay, keep in mind when you're dividing by 10, just move your decimal one spot over. So 1.5. Okay, so now if I look here, y equals 1.5 back over here. 1.5 is looking pretty good. Okay, so MS2 was just a touch off there. Okay, now the problem is though, that's one of the 2 parts I need, right? I need an x, y coordinate point. I need an x value too. Okay, now when I'm doing this, you're going to take this guy and you're going to substitute again. So it's like 2 substitutions. Okay, now I can plug it into either original equation. Well, if I'm looking at these 2 equations, which one do you think I'm going to plug it into?
X.
Yeah, I'll plug it into this small, easy one. Why would I put it into the hard one if I don't have to? All right? So I'm going to take this guy, and we're going to plug it right back in. Okay? You can plug it into either one, but I would pick the easier of the 2. Okay? So now I've got x equals 2 times 1.5. Well, what is 2 times 1.5? 3. Very good. So x equals 3. All right. So now you write your coordinate point. X, y. So 3, 1.5. Okay. All right. So let's try another one. Okay. Now this time we're not going to graph it. We're just going to do the math, the algebra behind it. Okay. All right. So now again, I have a y equals. Again, it doesn't matter if it's x or y. I just need one of them. Okay. Y equals. So I'm going to plug into the y, and what am I going to put in place of that y?
3x minus 8.
3x minus 8. Okay, so I'm going to take this guy right here, and I'm going to plug it into the y. Okay, so in this case I have 3x minus 8 instead of the y, so I'm replacing him, equals 4 minus x. All right, Guadalupe, what do you want to do to start solving this?
Add the x over.
That'll be fine, yeah. So we can go ahead and start by adding x. So I have 4x minus 8 equals 4. All right, and what will be the next step here?
Add the 8. No.
Yeah, that's right.
Add the 8 over.
Yeah, good. Add the 8, so I get 4x equals 12. So what's x going to equal in this case?
3.
X equals 3. Divide by 4, x equals 3. Okay. All right, so now I'm going to take this, right, and plug it back into one of the originals. Does it matter which one?
No.
No? You guys want to do the first one or the second one? Second one is one I would have chose too, okay? All right, so I'll plug it back in, so x equals 3, I'm gonna plug in 3 for x. So y equals 4 minus 3. So y equals what? 1. So now what will my final answer here be? 3, 1. Okay, all right, flip it over on the back side, let's try number 3. Okay, now on number 3, do I have an x or y equals?
No.
No, that's a problem, okay? Now, here is my rule for you, okay? Pick the variable that has a 1 or a negative 1 in front, okay? Because if I don't, you guys are all obsessed with solving for y, right? Because that's what we've been doing over and over and over, and we'll get into graph for the last few sections, okay? But if I look here and I solve for this y right here, and I subtract the 2x over, right? So I have 7y equals 3 minus 2x, and then divide by 7. Do you all like working with 3 7s and 2 7s?
No.
No, nobody does, all right? So be smart, okay? Pick the variable that has a 1 in front, okay? Or a negative 1, okay? If there's not a 1 in front, do negative 1 if you can, okay? So that's my rule of thumb. Find the one that has a 1 in front, and that's the guy we're going to get by itself, okay? Because if I get the x by itself, what am I going to do to make that happen? How do I get this guy by itself? Just add the 1 over, right? So I will have x equals negative 4y plus 1. No fractions. That's much easier to work with. Does that make sense? Now, once you do that, though, when you take this guy and rewrite him and change him a little bit, you can't use him anymore. He's out. Okay? So when you added that 1 over here, you're going to take that guy out of the game completely. All right? I mean, he's got like a major injury. He's got like a knee injury or something. All right? He's out. He can't come back. But this guy can, because it's the same thing, just wrote a little different. Now that you have an x equals, where do you think you're plugging this guy in for?
The X in the top.
Good, the x up on top. X equals, plug it in for the x. Okay. So I'm going to have 2 negative 4y plus 1 plus 7y equals 3. Again, I'm just taking that x out and putting this guy in its position. Okay? All right. Chloe, what's the first thing that needs to happen here?
Distribute.
Good. So we have negative 8y plus 2 plus 7y equals 3. So first thing we do is distribute. Okay, Kevin, what's the next thing that needs to happen here?
Subtract 2.
Okay, you can do that. Let's go ahead and put those together first for me, though.
Okay.
Okay, so we'll combine for like terms first. So negative 8y plus 7y is? Negative 1y. Okay, plus 2 equals 3. Now, Kevin's right. Okay, now let's subtract the 2 off. So negative 1y or negative y equals 1. And then what will we do our last step? Good, divide by negative 1. Daniel, write this down. What are you doing? So y equals negative 1. Okay. Now, what do we do with this guy? What do we do with him? Okay, what we say one's the original, so it's either going to be this one or this one now. So out of those two, which one are you probably going to use? The bottom one, because if I'm going to plug in y, I'm going to plug it in right there, and there's just a quick problem I had to do. Okay, so I'm going to take it and I'm going to plug it in right there. Guys, I'll give you a hint. Usually, if you have solved and have an x equals and y equals, that's the one you want to plug into. Okay, that'll be the easier. Okay, all right. So we have x equals negative 4 times negative 1 plus 1. So what do we get there? What's x equal? 5. Very good. So now what would my final answer here be? Good. 5, negative 1. Okay. So now I'm going to write a rule off to the side here.